Hey, moving right along with our trig functions unit. Today we're going to take a quick look at graphs of reciprocal trig functions. So basically those secondary trig functions, the secant, cosecant, and cotangent, the ones that I kind of hate. But they make kind of cool graphs, or at least different graphs that we can't get any other real way. So let's jump in and take a look at what those look like. And we're going to learn how to graph them by hand. Of course, you can always go to Desmos later, but seeing where they come from and why they come the way they do is usually helpful in working with them. So we're going to want to graph our three secondary trig ratios, the reciprocal functions. And we're going to start off by thinking about what their equivalent primary trig ratio is. So when I see cosecant, that's really 1 over sine x. At least that's how my brain thinks about it. 1 over sine x, because that's pretty much what it is by definition. Now here's how I graph reciprocal trig functions, and I find it fairly straightforward. Let's start off by graphing the primary trig equivalent of it and go from there. So the sine function is going to go 0, 1, 0, negative 1, 0. So it goes up to 1, back to 0, down to negative 1, up to 0. Now what we'll do if we want to actually graph the real function is take the reciprocal of each of the individual points. So I'm going to put a bunch of points on here and say, okay, this one right here, what's the reciprocal of 1? Well, it's 1 over 1, which is still 1. What's 1 over 0? 1 over 0 is undefined. That means this function will not be defined at that point. It also will not be defined at that point. It also will not be defined at 2 pi. So there's 3 vertical asymptotes there. Now I just have to say, okay, what happens to a function, or what happens to a fraction, I guess, when the bottom gets close to 0? So something like 1 over 0.0001. 1 over 0.0001 is 1,000. So as I get closer to 0, I'm going to go to infinity. So my point of 1 there is going to go upwards towards infinity there, and upwards towards infinity there. Similarly, down here, 1 over negative 1 stays negative 1, but as I'm approaching a value of 0, which over here I am approaching 0, 1 over that approaches infinity. And I'm not being too careful to get exact values, but if I wanted to guess a few of them, for instance, right here we have about 1/2, so 1 over a half is about 2. 1 over a quarter is about, now it would actually start being a little higher. It should be about 4 up there somewhere. But that's the rough shape. And I know that our graph only goes from 0 to 2 pi, but really quickly, I'm just going to kind of show you that if you did it further, what you'd see is it ends up looking like this. Which is kind of interesting. Again, feel free at any point to go over into Desmos and try it. I believe Desmos will take cosecant x. If not, you can always plug in 1 over sine x and it will graph it for you. Okay, secant, extremely similar to that. Secant is 1 over cos x. So if I want to draw cos x, it goes like this. And by the way, drawing primary trig ratios should be almost second nature to you at this point. Drawing them in radians should almost be second nature, especially when they're broken down in quarters of a circle like this. And then you're going to have asymptotes wherever there's a 0, because anytime you get 1 over 0, it's undefined. Cos is 0, so undefined when I take its reciprocal. And then this one looks like this. That does not look remotely symmetric. I will try to make it look slightly more symmetric. And then this one goes up. So it basically, much the same way that cos and sine look the same, they're just kind of off-centered. This is the same shape as this, just off-centered. Shifted over a little bit, if you will. Okay, cotangent is 1 over 10x. 10x has a 0 here. I want to be careful about the colors I use, just so it's not confused. 10x does have a asymptote at pi over 2. And if you think about it, tan theta is sine over cos. Cos has asymptotes. Cos has zeros at pi over 2 and 3 pi over 2, so tan should have asymptotes at those values. Okay, and tan actually looks like this. At 45 degrees or pi over 4, it's 1. It actually goes like that. And from there, it's -1, +1. Like that. And same thing there. Okay, so that's what the tan function looks like. Now the inverse tan function is 1 over that, which means wherever there's a 0, there becomes an asymptote. And interestingly enough, wherever there was an asymptote, there becomes a 0. The asymptote is essentially infinity. Its reciprocal is 1 over infinity. 1 over infinity is 0, or at least effectively 0. Keeping in mind, infinity is not really a number, it's a concept. Okay, so now we start thinking about this. Well, that's 1, so its reciprocal doesn't go anywhere. That's -1, its reciprocal doesn't go anywhere. Doesn't go anywhere, doesn't go anywhere. And again, as you approach 0 here, you're going to approach infinity, and what you're going to get is a graph that looks like that. And that. So what makes this one interesting is that cotangent looks to have the exact same shape as the tangent. It's just mirror image left to right and shifted over a little bit. That's kind of neat. All right, again, feel free to play with that in Desmos if you'd like to. And now I'd like to talk about notation that makes me angry. I don't know who came up with this or why, but someone screwed this up. Okay, so let's just try question 2. We have 1 over x squared, and we want to evaluate that for x equals 2, so I'm just going to say that that's 1 over 2 squared is 1 over 4. Pretty easy. Let's do the same thing for x to the -2. X to the -2 is 2 to the -2, which is 1 over 2 to the +2, which is 1 over 4. Exactly what you think it would be. Because we're always taught that a negative exponent is a reciprocal. It's just 1 over the value. Similarly, 1 over x is just 1/2. This becomes 1 over x when you take the reciprocal, which is just 1 over 2. Okay, so what that means is that these two are the same. They mean the same thing. These two mean the same thing. Now we get to this. The -1 exponent. Now this is where it gets weird, because if you think about this closely, the -1 exponent is not on the 1/2 or the sine of 1/2. It's on the sine and only the sine. So it's not the reciprocal of a value, it's the reciprocal of a function, which is a completely different thing altogether. So let's see how we evaluate these. Cosecant 1/2. When I plug that into my calculator, and what I'll punch into my calculator actually is just 1 over sine 1/2. And I'm going to do this in radians because 1/2 does not look like a degree measurement. So let's assume radians. So make sure your calculator is in radians to start with this. And we'll punch in 0.5 sine and then 1 over that. And I'm going to get out about 2.086-ish. Okay. Now sine -1, that's a completely different thing. On most calculators, this says punch in 0.5 or 1/2 and then do a second function sine or an inverse sine. So I'm going to punch 0.5. In my calculator, it is second function. Go away. Seriously, go away. No, go away. As soon as I start back, there's going to be another one. I know it. Stupid computer make a liar out of me. Okay, so I punch in 0.5 second function sine. And again, your calculator might have an inverse button or a shift button. Mine's a second function. And when you do that, this is going to be 0.524, I guess it rounds to. Okay, so they're different numbers. That in itself is a little bit of an issue. There's an even bigger issue. Over here, with this one, cosecant of 1/2. 1/2 is an angle. Cosecant of 1/2 is a value. Kind of get what I'm saying here? So just as an example of that, if you're kind of confused what I mean, if I just took, for instance, sine of 30 degrees equals 1/2, the 1/2 is a value. It's not an angle. It's just a value. The 30 is an angle. So over here with cosecant 1/2, my answer is 2.086, but it's a value. Sine inverse of 1/2 is actually an angle. That's basically rearranging this equation to get something like sine -1 of 1/2 equals 30 degrees. So when we have it in this form, it's a value. When we have it in this form, the answer is going to be an angle. That's a pretty drastically different thing. So this notation is very, very strange. It doesn't change the math. It's a weird notation. Similarly, secant 1/2 is 1 over cos 1/2, the 1/2 being an angle in radians. So 0.5 cos 1 over is 1.139. And again, just as a reminder, that's a value, not an angle. Cos inverse of 1/2, 0.5 second function cos is 1.047. And that is an angle in radians. It's about pi over 3, a little bit less than that. So pi over 3 would be 60 degrees. I'm guessing that's about 50-some degrees, 58 degrees, 59 degrees. In fact, I guess I could always do it in degrees. 0.5 second function cos. Oh, it's exactly 60 degrees. Yeah, yeah. So I guess 1.047 is pi over 3. Hey, it is. What do you know? Okay. So now that I've introduced you to the really bad notation that's super confusing, I'm going to give you an opportunity to go and try some homework questions with it and hopefully minimize the amount of bleeding that your ears do as your brain tries to comprehend these weird things. The good news is I don't think the reciprocal functions are that tricky to play with. Just the notation of the inverse. The reciprocal trig functions versus the 1 over, or sine to the negative 1, cos to the negative 1 inverse functions. Anyway, let me know if you've got any issues. If not, I'll see you in the next lesson.